Electrically held lighting contactors use an electromagnet to hold the contacts closed. Operationally, when voltage is applied to the coil, the electromagnet creates a magnetic field that holds the contacts in the closed position. When voltage is removed, the magnetic field collapses, and a spring opens the contacts. The advantages of electrically held lighting contactors are that they are compact and lightweight, they have a fast response time, and they exhibit low power consumption. The disadvantages include the fact that they require continuous power to stay closed. Electrically held lighting contactors are often used in switching lighting loads in residential, commercial, and industrial applications, as well as in the control of small motors and pumps. Mechanically held lighting contactors use mechanical force to hold the contacts closed. A mechanical latch or cam is used to keep the contacts closed. When a release mechanism is activated, the latch or cam is disengaged, and a spring opens the contacts. The advantages of mechanically held contactors are, firstly, they do not require continuous power to stay closed, and secondly, they are more robust and durable than electrically held contactors. The disadvantages include that they are larger and heavier, and they have a slower response time. Mechanically held lighting contactors are typically utilized in switching large lighting loads or multiple lighting circuits in commercial and industrial environments and in the control of heavy motors and machinery. Considering the comparison of applications, electrically held contactors are suitable for small to medium lighting loads and are used in applications where continuous power is available. Mechanically held contactors are suitable for large lighting loads or multiple circuits and are used in applications where power outages or interruptions are common. They can also be utilized for control of heavy motors and machinery. In summary, the key difference lies in how the contacts are held closed. Electrically held contactors rely on continuous power to an electromagnet, while mechanically held contactors use a mechanical latching mechanism. Firstly, consider the load size. Electrically held contactors are best for smaller to medium loads, while mechanically held contactors are designed for larger loads. Secondly, assess the importance of power consumption. If energy efficiency is critical, mechanically held contactors are preferred as they don't require continuous power. Thirdly, think about the application. For frequently switched loads where speed is important, electrically held contactors are suitable. For loads that need to remain on during power outages, mechanically held contactors are the better choice. Fourthly, reliability matters. Mechanically held contactors are more robust and can withstand harsher conditions. In detail, consider these technical factors for electrically held contactors. Coil voltage is an important specification, ensuring it matches the control voltage available. Common voltages include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. Contact ratings. The current and voltage the contacts can safely handle should be selected based on the load requirements. For mechanically held contactors, latching mechanism is important. Understand the type of latching mechanism and its reliability in holding the contacts closed. Tripping mechanism is important also. Review the mechanism for releasing the latch, whether it's electrical or manual, and ensure it meets safety requirements. Consider also the inrush current. Lighting loads, especially with ballast, can have high inrush currents. Select contactors with appropriate inrush current ratings. For motor loads, consider the motor's horsepower and full load amperage to choose a contactor with adequate ratings. Environmental conditions can matter. If the contactor is installed in a harsh environment, select one with appropriate environmental protection ratings such as NEMA 3.4 or 4X. Control wiring is also a key consideration. Ensure proper wiring practices are followed, and use appropriately sized conductors according to the National Electric Code or NEC. Safety features is next. Look for contactors with built-in safety features such as overload protection or short-circuit protection. Maintenance is also a key factor to think about. Regularly inspect the contactors for wear and tear and perform necessary maintenance to ensure reliable operation. Here are some additional points to consider. Electrically held contactors are generally less expensive than mechanically held contactors. Mechanically held contactors are more suitable for applications where the load needs to remain on during a power outage, such as emergency lighting. Both types of contactors can be controlled manually or automatically using a variety of control devices such as switches, timers, and programmable logic controllers or PLC. When selecting a lighting contactor, it's important to consider all of these factors to ensure that you choose the right contactor for your specific application. Here's a breakdown of specific applications. For residential lighting, electrically held contactors are commonly used for switching lighting circuits. For commercial buildings, both electrically held and mechanically held contactors are used depending on the size and type of lighting load. For industrial facilities, mechanically held contactors are often used for controlling large lighting loads and heavy machinery. In agricultural settings, mechanically held contactors are suitable for controlling irrigation pumps and other equipment that needs to operate reliably during power outages. For emergency lighting systems, mechanically held contactors are essential to ensure that the lights remain on during a power failure. Consider energy management systems. Lighting contactors can be integrated into energy management systems to optimize lighting control and reduce energy consumption. Dimming control. Some lighting contactors are compatible with dimming systems, allowing for further energy savings and improved lighting control. Surge protection is important. Incorporate surge protection devices to protect contactors from voltage surges and spikes. Consider harmonic distortion. In applications with electronic ballasts, harmonic distortion can be a concern. Select contactors that are rated to handle harmonic currents. Coordination is essential. Coordinate the contactors over current protection with the upstream protective devices to ensure proper system protection. Proper grounding is always important. Ensure proper grounding of all electrical equipment to prevent electrical shock hazards. Lockout-tagout procedures should be established and followed to ensure safety during maintenance and repair work. Safety training is also important. Provide adequate training to personnel who install, operate, and maintain lighting contactors. Consider future expansion. Choose contactors that can accommodate future load growth or system expansions. Document your system. Maintain accurate documentation of all lighting contactor installations, including wiring diagrams and specifications. Review standards. Stay up to date with relevant industry standards and codes to ensure compliance and safety. Conduct regular inspections. Perform periodic inspections of lighting contactors and related equipment to identify potential problems before they lead to failures. Consider preventative maintenance. Implement a preventative maintenance program to extend the life of lighting contactors and minimize downtime. Consider arc flash hazard analysis. Conduct an arc flash hazard analysis to determine the appropriate personal protective equipment or PPE requirements for working on or near lighting contactors. Use proper tools. Use appropriate tools and equipment for installing and maintaining lighting contactors to ensure safety and accuracy. Secure connections. Ensure all electrical connections are tight and secure to prevent overheating and electrical faults. Labeling is also important. Clearly label all lighting contactors and associated control devices for easy identification. Consider voltage drop. Calculate voltage drop in lighting circuits to ensure that the voltage of the load is within acceptable limits. Wire management. Use proper wire management techniques to keep wiring neat and organized. Consider energy audits. Conduct periodic energy audits to identify opportunities to improve lighting efficiency and reduce energy costs. Recycling considerations. Properly recycle old lighting contactors and other electrical equipment in accordance with environmental regulations. Stay informed about new technologies. Keep up to date with new technologies and trends in lighting control to improve efficiency and performance. Consult with experts. Consult with qualified electrical engineers or contractors for assistance with selecting, installing, and maintaining lighting contactors. Review the local electrical code. Comply with all applicable local electrical codes and regulations. Be aware of common problems with lighting contactors such as contact wear, coil failure, and mechanical problems. When troubleshooting lighting contactors, use appropriate test equipment, and follow safe work practices. If you are not qualified to work on electrical equipment, contact a qualified electrician. Finally, remember that safety should always be the top priority when working with electrical equipment.